What's up, boys and girls? Tweety here. Welcome to another episode of Human Resource Machine. Let's do this. Okay, so the re-coordinator. Alright, so me, yes I win. I find the game is most enjoyable when playing against the best player I know. Myself. Yeah, I do that too. For each number in the inbox is an address on a tile on the floor. Send it to the outbox. Okay, so what this is saying is that this represents this number 1 here. And so we want to find column and then row. So it's in column 0, row 1, right? Okay, so let's see. Let's do this. Brain fart. Okay. Inbox. Copy to. Oh, hold on. Alright, copy from that guy. Copy to that guy. And no. Copy that to there. So this is our column. This is our row. Whee! Okay. So, let's see, we're holding the column. So with that guy. If it's negative, then we found the column. Right? Add outbox, copy from row, and outbox, and then start over. Whoa. Okay. Gosh, it's windy. It's windy up here. If it's not, then we copy that to column, bump row, and then copy from column again and start over. Right? Alright, let's give it a try. So we're gonna starting on row 0. Okay. So we're saying we're in column 1, which is correct in the row. Do that again. Alright. Now 13 is here. So we should end up with row 3, column 1. Okay. Row 3, column 1. Now this should be negative, it should add it back. Put it in there. Alright, cool. Yay! Oh, we're at 15. Darn it. And 80. Let me see if there's something I can do to remove. So, there's gotta be something. can't see it. Let me try something. Try moving all of these up here. Alright, so that's where we want to be anyway. But we want to skip that. And then this would just come up here. Yeah, that doesn't help us, does it? So jumps, coming from 14, coming from 12. Inbox, copy 2. Oh, you know what? We don't need this. That's what it is. We can sub it right away, and then copy that to column if it's not negative. And then, okay. Yeah, there it is. Sweet. And 73. Yes. I think that's from moving this stuff up here. So it comes in and just falls through instead of having to jump all the way back up and do this jump over and over and over. All right, continue to elevator. Let's do digit explorer. Ooh, our users have been rating some of our hardware products with 1 star. With users' reviews citing draws too much power and overheats. Numbers are too complicated for test subjects. Occasionally removes alarming volume of skin from human user. Management has come up with a solution. Make the numbers smaller and easier to understand. Okay. Grab each number from the inbox and send its digits to the outbox. For example, 1, 2, 3 becomes 1, 2, and 3. Okay. Okay. So if we take the inbox, let's make a temp right here. Okay. And then copy to the temp. And we need something to count with. So let's copy from this one, copy to there, copy from this, copy to there. Okay, we put there, and then no, maybe we don't need this one yet, like we did on the last one. So if we sub with 100. Yeah, okay, so let's try this. Sub that one. Hundreds. Hundreds. Tens. Alright. This is our ones. Oh, be right back. Okay, we back. I went ahead and took the liberty of finishing this off camera. These ones on this side are tough. I went ahead and did both of them. Oh man, I spent hours. Mostly on the other one. You'll see. Anyway, so this one is fairly straightforward. We have we copy 0 into the hundreds, tens, and then we grab from the inbox, we sub with the 100 spot. If that is, if we can subtract from it, that means that this number is, the number that's in here is bigger than 100. So we copy it to temp, and we +1 the hundreds spot, copy from temp, and we do it again until it's negative. That means that this number, oops, okay, this number is bigger than what we are holding, and then we add it back so that we don't have a negative number. And then we subtract with the 10, and we do that again, same exact thing up here, but in the 10 spot. We might be able to do something with a pointer or something. I'm not sure. Like, maybe we could do a pointer to 0, and then we could have the same code just using the pointer, and then we have something, you know, we tell it either to put this one in there or this one, but I didn't do that. Anyway, so it does that again until we are less than 10. Keeps bumping this up as long as it's over, and then we add 10 back, which gives us back our original, and we copy that to temp. And that's because we need to go hundreds, tens, and then ones. So then we copy from hundreds. If that's 0, that means that our number is lower than 100. So we skip that, go down here, and if it's copy from 10, if that's 0, that means that our number was lower than 10, so then we come up here, copy from temp, outbox. If it wasn't 0, then we go here, outbox, copy from temp, outbox, jump back up to the top, start over. If this copy from hundreds wasn't 0, we outbox it, copy from tens, outbox, copy, yeah. So here we go. Go fast. Yay! And I got my size challenge. I'm not worried about the speed challenge on these ones. Let's just go to the prime factory. So this is prime factorization. I'll do this. Are you sure you're supposed to be here? This is very difficult assignment. I have no idea how to do it either. So basically what we want to do is right, so if we have 12 and 7, the outbox should be 2, 2, 3, and 7, because 2 times 2 is 4, 4 times 3 is 12, and 7, there's nothing except for 1 times 7 that would work for this, so we're not worried about 1 time this, because actually it'd be 1 times 2 times 2 times 3 would be 12, and then 1 times 7. Weird. Thank God, not worried about 1. Because yeah, my mess over here is crazy. But I don't care. I didn't make any of the challenges. I'm just glad I was able to make it work. All right, so let's start with the prep. We copy the 0. Let's make that 0. Oops. I do 0. And then we copy to here, 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 and here. So those four: the pointer, the index, the quotient, and the factor or the divisor. And then we bump the factor divisor 2, giving us a start of 2 as our start divisor, because we don't need to worry about 1, and we can't, and we don't worry about 0 either. Okay, so then we inbox, copy to dividend, copy to remainder, and then we ask the question: does this divide evenly with the factor? So that we set with the factor. If it's 0, that means we have divided evenly. If it's negative, that means that it has a remainder and we need to do something. But keep doing this, bumping the quotient, copying the remainder to remainder, bumping the quotient until we get negative or 0, and we copy from remainder here, jump back up to here. Subbing with that again. If it has a remainder, then we bump the divisor or the factor, copy from the dividend, and start over. Copy to remainder, copy from 0, copy to quotient. That resets the quotient, and then we jump up to here, which copies from remainder, jumps back up here, start subbing again. Does that one divide? So we bump this one up to 3, and then we check to see if that divides evenly. And then if it doesn't, it'll bump it up to 4 and see if that divides evenly. Then 5, 6, and then 7, and so on, until it can divide evenly. If it does divide evenly, then we bump the quotient, copy from factor, copy to an index, bump the index, copy from the quotient, subtract from the factor divisor, which that's our exit condition. Check to see if that's negative. If it is negative, that means that our quotient is now larger than our divisor, right? Or no, our divisor is larger than our quotient, so we know we're done. And then we jump down here to our exit condition. If it's not, then we add back to the factor divisor to get our original thing from quotient, copy to dividend, and then copy to remainder, jumps back all the way up here, copy to remainder, copy from 0, copy to quotient, this jumps back up, copy from remainder, jumps back up, and then ask the question: does it divide? Our exit condition is just copy from whatever pointer is pointing at, outbox it, bump pointer, and then subtract with the index. If that's 0, then we know we're finished and we can start over all the way back up to the top. So yeah, here we go. This took me so long. I'm just glad I was able to do it. So we got a 9, or we got a 2. So this should be 2 times 3 times 3. There we go. Slow down a little bit so you can see what's going on. This takes a while. So this is going to go all the way to 7 before it copies down. And once we're done, so we grab 3. This one's going to go to 3. And we're done. After it resets everything, of course. Yeah, it's like, yeah, 39. Yeah, speed challenge is way off. So, continue to elevator. Alright. Almost done. Sorting floor. I have 8 minutes before my timer runs out. Hey, check out this new office. You've really climbed the corporate ladder together. Thank you. My servicing skills truly are adequate. Your skills are pretty good too. Whatever it is you do over there. So are you ready? Yeah, I'm ready. Alright, so 0 terminated strings, and then we got to sort. This is like how to get everything from here before it gets to 0. Okay. So let's do some stuff here. Alright, so we copy from 24, copy to, right, so 0. And 20 is going to be our index. Right. We copy in, bump to index. This is also going to copy to the 0. So our exit condition can go down here, where we would. What do we want to do here? What if we put it up here? Let's. No, I just don't want to re-copy that in there. Copy from 0, copy to index, copy from the pointer of index. Oh, you know what? That's going to be, index is going to be all the way at the end. Copy to index. Let's, yeah, so let's bump index down. Copy from index. We'll do biggest to smallest. These need to be, yeah, so we want smallest to biggest. So smallest, biggest. And so then we copy from index and we outbox and we jump to there. If this is negative, that means we're done. And we can start over. Okay. That's if it's 0. If it's not 0, let's see. Let us. Let me think about it. I'll be right back. Okay, I'm back. Ready for this crazy? All right, so copy from 0, copy to size, copy to count. Take the inbox, copy to size. The pointer of size, that is. Copy from the pointer of size. That's because this condition down here, I think. I guess I could just put it there. Right. It's the only thing. That's what I did right. Yeah. Copy to temp. Jump if 0. That means we've reached our 0. Copy from size. So that's the actual size. subtract that from the count. If it's 0, come down here. Bump size, copy from 0. Jump all the way back up here. It's a crazy mess. I'm just gonna let it run. Let you guys see it. Copy size, copy count, inbox to there. Put it in temp. 0 plus what on size. We reset the count. Put in 25. Put it in temp. We're at 1. So we're going to subtract with that. So we know that that's the biggest number. And the count. And we compare. And then we reset. Grab the next one. Put it down. Check. We're at 2, size 2. So we check to see if which one's the bigger wood out of that one. It's the one that's on the in the correct spot. Grab from there, put it back down to temp. Subtract. It's a mess, I know. So we know that we need to swap these two. Right? And we're at 0. And we're at 0 again. Oh. Alright, now we're gonna start counting down. Putting everything away. Oh. It's negative. Reset everything. Compare. So we know we need to swap those. Oh, I shouldn't have changed that. Alright, undo. Yeah, this copy from here needs to be there. I think it has to do with something around here. With these. Copy to count, inbox, copy to size. Copy from size. You know, I don't know why it matters, but I think it does, because it should have grabbed that other one and put it into temp. I think. I think what I could have done to somehow make this a little faster. So we got to this one. It wasn't. This one was the bigger one. You see, these ones had to swap. Something that's really long, like this coming up. Probably would have been nice to, like, we know that this one is the, you know, it goes in between these two. So let's just push all of these, the rest of them down. And then, you know, swap, and then put this one where that one was supposed to be. So like here. So it's going to get to here. It's going to say these ones need to be swapped. This one's going to get to here, so this one needs to be swapped with 2. Right, and then it should just be like move moved all the way down. Alright, so these ones swapped, and then these ones swapped, and then these ones are going to swap. It would have been more efficient to just say move all the rest of them down and just insert. So like this one should go in between these two. Just move everything down one and then insert. But I didn't do it that way. I did it this way. But it does work. It's terribly inefficient. Terribly. Beep, 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 beep. It's definitely more efficient than a bubble sort, I think. But I could probably explain a bubble sort if you guys don't know. So a bubble sort would like put all of them down in the order that it came. Then just start with this one and compare until it found the largest one and then swap. And then it would keep going until it found exactly the largest one. And then it would move to this one. So we know this is the largest. Move to this one, find the next largest, and it would go to this one and then this one. Compare these two, compare these two, compare these two, compare, and only swap if this other one is bigger. And then it would move to this next one. Compare. Mine is starting from here and comparing what it got. So it already knows that we already have a sorted list. Yeah, it just could have been a little bit more efficient with. With some things. But it works. Speed it up and let it finish. Actually, no, somebody from school did a recursive bubble sort. That was pretty funny. Needless to say, his computer didn't, or his code didn't compile. And we are done. I think we're in the thousands. Let's see. Yeah. Alright. But we are done. We've got a light on that one. Let me know in the comments if you want me to go through all these guys and try to get all these challenges, so I'm not going to worry about it. This will be the last episode, and we'll just finish up with this final.
Congratulations. You've really become an invaluable instruction follower.
Yes, don't worry, your job is safe.
Oh.
We've replaced you with this electronic box.
It's called a computer. It iterates through a list of simple instructions called a
Call me
program.
simple.
It has a small amount of memory to store data while processing, like tiles on the floor.
It has inputs.
And
Registers.
outputs.
Its simple instructions can be used together in infinite combinations to compute just about anything you can imagine.
A truly efficient worker that never sleeps.
It's going to change everything.
It's gonna.
Please take your things.
Is it Turing
and
complete?
enjoy whatever it is you people do out there.
Where's the
Congratulations.
Yay, we've finished. Oh, there we are. Coming down. Coming down. We got some nice old cars right here, looks like. Up in the foreground. It's funny that my character doesn't see anything that's going on. It's pretty funny. Yay! All done. Well, thank you for watching. next time playing some other game. Like it if you like it. Look at that, Carol. Like it if you like it, dislike it if you didn't like it. Let me know what you liked or didn't like about it in the comments. And we'll see you next time. Until then, I'm out here.